The oxy-fuel gas process is an essential and versatile tool for those working with metals. Every day it's used in industry, schools and laboratories. The operating procedures have been refined over many years. The result is a process which is not only efficient, but one which also has a first-class safety record.
In this fabrication yard, welding and cutting equipment is in constant use, and the operators are well trained and very experienced. However, we all know that when you're doing something every day, it's very easy to get into bad habits, something we all have to guard against. Here down on the farm, it's a different story. This equipment only comes out for a one-off job or if there's a breakdown, so it's easy to forget something. This film is not intended to teach you how to weld or how to cut metal. What it will do, however, is show you how to handle the equipment safely. Caution, common sense, and a few simple rules.
The safe, professional handling of this equipment must be of prime importance to all those concerned with its use. In addition, you have a legal obligation to protect yourself, your colleagues, and the public from harm. There's no shortage of guidance for the operator. There's a comprehensive range of laid-down standards from the specification of the cylinders right through to keeping the working environment safe. In particular, the codes of practice issued by the International Gases Committee of the CPI and those provided by the British Compressed Gas Association lay down the guidelines for safe operation. All these operations are based on the gases contained under pressure in cylinders like these. We'll be dealing with three of the most commonly used gases: propane, acetylene, and oxygen. You can recognize them from the distinctive color and shape of their cylinders and from the labeling. Any cylinder whose contents cannot be positively identified breaches regulations and must not be accepted. Acetylene is a highly flammable gas. As little as 2% in the air can explode. The acetylene cylinder is filled with a porous mass which contains acetone, a liquid in which the acetylene is dissolved. When an acetylene cylinder has been laid on its side, it should be allowed to stand with its valve uppermost for at least 1 hour before use. If not, liquid acetone may be blown out when the valve is opened. If acetylene is allowed to come into contact with copper pipe like this, or silver, it can form a highly sensitive explosive. In addition, acetylene is lighter than air, and if released will tend to rise. It's also an asphyxiant with a characteristic garlic smell. Propane, like acetylene, is highly flammable. It's a liquid under pressure and should be stored and moved with its valve uppermost. The vapor is heavier than air and will tend to migrate to low areas. It, too, is an asphyxiant and has been given a distinctive fish-like smell. Oxygen is supplied under high pressure in black cylinders, and while not flammable, it does support combustion. In normal air, a spark or flame from welding may cause flame-proofed cotton overalls like these to smolder. In an oxygen-enriched atmosphere, however, materials burn much more quickly, including some like these overalls which don't normally catch fire. With an oxygen concentration at around 50%, flame rapidly spreads across the material. Hair is affected in the same way. Even with help arriving very quickly, it would probably be too late for anyone wearing these overalls. Never use oxygen as a substitute for compressed air. Also, high-pressure oxygen reacts violently with oil and grease. It's important, therefore, to use only clean cloths to wipe cylinders and fittings. Greasy hands and gloves should be kept well away. Lubricating these fittings is unnecessary and highly dangerous. Oxygen has no warning smell. It's on the properties of these gases and their cylinders that the guidelines for handling and storage are based. These cylinders are heavy-duty pressure vessels with a tough valve that exceeds British and ISO standards. These key-operated valves, fitted to BOC cylinders, may be safely used as a lifting point. Others can be carried by the guard. It's important that the cylinders are handled correctly. In particular, they should always be lowered to the ground gently. They may be churned over very short distances, but the safest way is upright and secured in a cylinder trolley. Ideally, all cylinders should be stored outside in a secure area protected from the weather. In any case, it should be well ventilated and away from sources of ignition and other flammable or corrosive materials. Oxygen must not be stored with fuel gases, and the two should be separated by a minimum of 3 meters, or alternatively, by a fire-resisting wall. The same segregation should be applied to empty cylinders, which should have their own storage area. All cylinders, in storage and in use, are best kept upright and properly secured. So, now we can identify the gases. We're aware of their properties and how to handle and store them safely. Let's look at putting them to use. The cylinders should, of course, be upright and secured. The fittings and connections required are pressure regulators, flashback arresters, hoses, hose check valves, a blowpipe, and the appropriate mixer and nozzle. All equipment should be checked before use. First, on the cylinder itself, examine the valve seats. Any moisture or particles of dirt should be removed, either by compressed air or by momentarily opening and closing the valve using the cylinder key. This is known as snifting. It's an operation never carried out with hydrogen, which can ignite spontaneously. Next, suitable pressure regulators. Check that all the threads are in good condition, that the bullnose connection is free of contamination, the inlet filter's in place, and that there's no damage to the seat. The regulators should be tightened down to secure a gas-tight seal using the correct spanner. Excessive force is not needed. All regulators must conform to British standards and be suitable for the pressure contained in the cylinder. The maximum inlet pressure is shown on the front in bars. Regulators also vary in their outlet pressure, and this too is shown on the front. 1.5 bar is the maximum outlet pressure for use with acetylene. Selection of the correct oxygen regulator depends on what it's to be used for. A 0 to 10 bar regulator is needed for heavy-duty cutting and heating. However, for most purposes, a 0 to 3.5 bar regulator is sufficient. If in doubt, consult the gas supplier. Regulators are always mounted with the gauges to the front and the cylinder valve controls to the right. All oxygen fittings have the normal right-hand thread. However, fuel gas fittings have left-handed threads, identified by a notch machined into the nut. This is a safety feature which prevents the accidental interchange of fittings. There are just 2 exceptions to this rule: propane cylinders for use on vehicles, and a few acetylene cylinders used for lighting. Next, the flashback arresters. These are safety devices which prevent flames traveling back into the cylinder. They must meet the appropriate standard and have a working pressure which exceeds that of the regulator with which they're being used. They're fitted pointing in a downward direction. They should be tightened with a spanner just enough to effect a gas-tight seal. Hoses, too, must meet the correct standards and be clearly marked as such. They're also color-coded: red for acetylene, blue for oxygen, and orange for propane. And once again, right-hand threads for oxygen and left-hand threads for fuel gases. Here at the blowpipe end, all hoses should be fitted with a hose check valve. It's an essential safety device, a non-return valve which prevents the back feeding of gases from the blowpipe into the system. Normally the hose check valves arrive already fitted to the hoses. The hoses should be inspected for any visual sign of damage or deterioration and, if necessary, replaced. Use hoses of equal length and no longer than necessary, as they can get in the way. Once again, excessive force isn't needed when tightening down. Now the blowpipe. This one's a combined cutting and welding blowpipe. Check for any oil or grease contamination, and in particular the neck of the blowpipe for thread damage or carbon deposits, which may suggest internal damage caused by a previous flashback. The blowpipe can now be connected to the hoses. Left-hand thread for fuel gas and right hand for oxygen. Next, the mixer for welding. This is fitted just hand-tight to obtain a gas-tight seal. And finally, a nozzle should be chosen which suits the particular job to be carried out. It too is fitted just hand-tight. The nozzle can also be adjusted for comfortable working by slackening off the mixer connection, rotating to the required position, locking in, and then retightening. The system is now fully assembled. Notice that the hoses are kept out of the way, are not too long, and are never wrapped around the cylinders. Let's go over it again. Cylinder, regulator of the correct inlet and outlet pressure, flashback arresters, hoses in good condition, hose check valves, blowpipe in good condition, mixer and correct nozzle fitted. Now, the setting up. First, check that the blowpipe valves are closed and that the pressure adjusting screws on the regulators are fully closed. Then, using the correct cylinder key, open the cylinder valves, acetylene first, checking the cylinder contents gauge to make sure there's enough gas. Next, the oxygen. Always open the valves slowly, as a sudden inrush of gas can damage the regulator. The manufacturer's nozzle data will give the correct pressure for the size of nozzle being used. Keep it handy. To set the pressure, open the acetylene valve on the blowpipe and then adjust the pressure on the regulator. After checking that gas is flowing, close the blowpipe valve. The same procedure is then repeated with the oxygen. This should be done as quickly as possible. As a matter of routine, newly assembled equipment should be tested for leaks with an approved testing solution, paying special attention to all joints. If there's any frothing, the system should be immediately depressurized and the leak corrected. Each joint should be wiped dry with a clean cloth. Immediately before lighting, the system must be purged. The acetylene blowpipe valve is opened and the gas allowed to flow for a few seconds. The valve is then shut and the same procedure repeated for the oxygen. It only takes a few seconds, but it's an essential safety procedure which prevents backfeeding into the hoses and reduces the risk of flashbacks. 90% of all flashback accidents are caused by a failure to observe this simple procedure. Before starting, make sure you're wearing the correct protective clothing. Feet guarded against sparks, slag and heavy offcuts, and goggles of an approved design. The blowpipe can now be lit. The acetylene valve is opened and, with a spark lighter at right angles to the nozzle, the gas igniting. Increase the acetylene flow until the flame ceases to smoke. Then the oxygen valve is opened and the flame adjusted to a clear, sharply defined condition. This type of blowpipe can be used both for welding and, with the addition of a suitable attachment, for cutting. To change over, the welding nozzle and mixer are unscrewed and removed. cutting attachment is then secured, just hand tight. Consulting the manufacturer's data for the size of plate to be cut, the correct nozzle can be selected and fitted. The regulators are then adjusted to the correct pressure, as was done for welding. And this system must also be purged. First, check that all 3 valves are closed. Next, open the oxygen blowpipe valve fully. This valve now remains open. Then open the cutting attachment oxygen valve. Check for gas flow at the nozzle, and then close the cutting attachment valve. Open the acetylene blowpipe valve, and again check for gas flow. Close the acetylene blowpipe valve. The attachment can now be lit. First, open the acetylene valve and light with a spark lighter. Trim the acetylene flow until it ceases to smoke. Open the oxygen valve on the cutting attachment. Adjust the flame, and finally depress the cutting oxygen lever to ensure that the oxygen is reaching the nozzle. To turn the blowpipe off, first close the acetylene valve, which will extinguish the flame, and then the cutting attachment valve. Both cylinder valves are then closed. When the work period is over or the operator leaves the vicinity of the equipment, however, a full shutdown procedure should be followed. First, extinguish the blowpipe flame as before, including closing both cylinder valves. This shutting down procedure is similar for both cutting and welding equipment. The gases which remain under pressure in the regulators and hoses are then vented to atmosphere, acetylene first, by opening the blowpipe valves until the outlet pressure gauges read 0. The same procedure is then carried out with the oxygen. Finally, all the blowpipe valves are closed and the pressure adjustment screws on the regulators turned to the fully out position to remove the pressure from the regulator springs. Not all systems have exactly the same lighting and shutdown procedures, and it is important that the manufacturer's handbook is consulted to ensure that the correct sequence is followed. Periodically, during working, cylinders will become empty. This will be evident from the cylinder contents gauge and by a noticeable deterioration in the flame condition. Before changing the cylinder, the full shutdown procedure should be carried out as before, and then the regulator removed from the empty cylinder. Cylinders should not be moved around with hoses and regulators fitted. Good housekeeping is an important part of using this equipment safely. Empty cylinders should be clearly marked and moved to the appropriate storage area. All equipment should be stored in a clean, secure area and checked before use. Damaged or defective equipment must be replaced immediately. Safety is the responsibility of all those who use or control the use of this type of equipment.
And it's also a legal requirement. Operators must be properly trained. This handbook explains very clearly the points made in the film. Make sure you get a copy and use it. If you're in any doubt, ask. The suppliers of gas and equipment have specialists on hand who'll give you any information you need. Remember, caution, common sense, and safe, efficient operating procedures. Every day, thousands of people use gas from high-pressure cylinders, and they use it safely. Let's keep it that way.